All right, so number 2 from 5.4. Let's just solve a triangle, and then we'll do some word problems, and we'll go from there. Okay. So first things first, let's write down everything they gave us. Oops, forgot to write the angle. And there's not enough information without that angle. So we have A. We have little a. Remember, the lowercase is the opposite side. Capital, lowercase. Just get into that habit for the next chapter. Capital B. We don't have it. Do we have C? Yes. Yeah, it is technically given. So how would you find B?
You have the given angle, that's the 90, and then subtract the answer from.
Yeah, if we subtract these two from 180, we will have capital B. What's capital B?
54.
54. Okay. All right. All right, so let's find lowercase b. Which trig function should we use to find lowercase b?
Or yours.
Yeah, that would work. Let's go ahead and write that down here. 54. Step 2. Okay. Tangent of 54, you said, right? That will equal the opposite side, b, over adjacent. I think that would be the easiest way to do this. There's not just one way. If you chose the wrong trig function, do you know how you can tell if it's wrong? Or if you should switch to a different trig? Yeah. Like, let's say you picked, just for fun, real quick. Let's say you pick cosine 36. Right away, you're going to see you picked the wrong one. Right? Adjacent over hypotenuse, they're both missing. If that happens, pick something else. So even if you picked at random, just change it if this happens.
So it doesn't matter what the top.
Yeah, you could do tan 36 and it would be 12 over b. So either way would work. You'd end up with the same b. Tan 54 is less work, so that one's a little bit better. But it doesn't matter. So let's multiply both sides by 12. So b is 12 tangent of 54. What is that on your calculator? 16.5. Whenever you do this, make sure, especially on your test, double check that you are in degrees if you're using degrees. Just go press mode, should tell you. All the TIs should tell you under mode. Okay. If you have something else, you'll have to Google it. 15, 16. All right, so there's one side. And we got the angle right here. Okay. So now find C. What trig function should we use to find lowercase c?
Sine 36.
Yeah, I could do sine. Sine of 36 would equal 12 over c, right? Multiply c on the left and right side. Divide by sine 36. So c is approximately 12 over sine 36. $20.42. Any questions on this example? Is it okay? Is it weird? Okay. Let's move on to some word problems. You guys okay on this page? Got you. Wait a bit. Got it? All right. Find the height of the tree. So a giant redwood casts a shadow 532 feet long. Find the height of the tree. If the angle of elevation to the sun is 25.7 degrees. So you're gonna have to draw this out on your test to help you out. I'm gonna try to pick some questions similar to these. Okay, nothing too crazy because it's an exam and there's only about an hour to change. So I'm gonna keep that in mind as well. My happy little tree here. Okay. Cast a shadow. 532, right? 32 feet. Put the sun over here, I guess. Angle of elevation to the sun. It's over here. It's a horrible drawing, but oh well. So as you can see, the height that we want is going to be this side, right? See if I can draw that a little better. A little bit better. Okay. We want to know this height. Call it X, I guess. I'm sure your tree looks better than mine, so it's all good. So technically, it should be coming down here, but who cares? You follow me, right? All right, so angle of elevation is right here. So I'm looking towards the sun, go that way. I didn't want to come down in the tree, so I went out here. That's all. Okay, but technically the height that we're actually finding is here. I just drew it stupid. That okay? It's not confusing, right? Okay. If I don't draw it again, let me know. It's weird. You like my son? That's true. I didn't do very well in art class, obviously. You're asking for too much now. I'm not gonna get that. That's good. Someone worse than me out there. All right, so we got our sides. What do you think is a good trig function? Find the opposite side. Yeah, I think 10 because we don't want to mess with the hypotenuse, right? So anything that doesn't have hypotenuse is good. We only care about that opposite side. Opposite, adjacent, tangent. So just solve for x and you're good. But once you have the picture, it's not too bad, right? Multiply both sides. This will cancel. So now x is equal to this garbage. I don't know what that is. Seems reasonable, right? 256-foot tree.
Put 25%.
Yeah.
Oh.
Was it not 25?
No.
Oh, yeah, this is a 5. 25.7. Okay. Any questions on the steps? Is that okay? All right, let's do one more. I think I have one somewhere. Oh, this one. Are you guys cool on this page? All right, one last one for 5.4, and we'll move on. Find the height of the flagpole. Yeah, well, just a second. Find the height of the flagpole. It's a little wordy, but it's all good. So from a point on the ground, $500 from the base of a building. An observer finds the angle of elevation to the top of the building to be 24 degrees. And the angle of elevation to the top of the flagpole on the building to be 27 degrees. Find the height of the flagpole. All right, let me read it one more time. So from a point on the ground, 500 feet from the base of a building, an observer finds the angle of elevation to the top of the building to be 24, and then the angle of elevation to the top of the flagpole on the building to be 27. Find the height of the flagpole. Okay. All right, so there's a building. I know that much. There's my building. There's a flagpole on top of this building here. and there's a rando standing, what, 500 feet away? Staring at the building, I guess. Okay, so he looks at the top of the building, and he says the angle is 24. Do you agree with that? Elevation, top. Then he does it again to the top of the flagpole. So that total is 27, so 3 more degrees higher. Okay. So we're gonna have to do 2 equations to find one for total height and building height, and we can subtract them, right? Do you see it? Because we can make one triangle, let's call this, I don't know, B, I guess, for building, and F for flag. So I could use a tangent to figure out B. Yeah, let me add one extra step here. I want to find the flag height. I'll call this capital T for total. If I subtract these two, do you agree that I'll have the F left over, right? That makes sense? And you can see that I have one big triangle using the 27 going all the way up. And then you have a 24 using the inner part. So I can use this triangle for capital T, this triangle for capital B. Is that idea clear? So let's find the total. So tangent of 27 degrees is equal to the opposite, right? This height, which is the same as this over here, T over the 500. So this is the triangle I'm using, the big one. You guys see what I'm talking about? So if I use another tangent and use the smaller triangle right here, 24, that can be equal to this height, which is what I call B, over this adjacent side. Do you see where this came from? Is that okay? So once you have these, you'll just subtract them. But first solve for T and B, of course. Multiply both sides by 500. So capital T is equal to 500 times tangent 27. What is that going to be? Um, 254.76. Make some more space. Okay, so that's the total building with the flagpole. So I'll do the same thing, solve for B. That would be the height of the building. So multiply both sides by 500. That'll give us B. I didn't write the feet just because I'm being lazy. Make sure you know that at the end you got to put feet, right? 1024. Okay, so the flag will simply be the total minus the height of the building, which is 254.76 feet minus 222.61 feet. What'd you get? 32.15. Cool. So there it is. Height of the flag. Do you understand how we or why we set it up this way, where this came from? Is the algebra cool? Do you see why we subtracted? Let me know. Okay, move on to 6.1 then if you're good. You guys cool on this page? All right, 6.1. Find the amplitude. Period. And phase shift. For so real quick, the general form for sine and cosine. It's in your book, but just in case you don't have it. I think this is the letters they use in your book. I forget. 90% sure this is legit. Each book uses different letters, so I don't really care. Now, amplitude is going to be the absolute value of this particular A right here for sine and cosine. Period will always be for sine and cosine 2 pi divided by the absolute value of this B. So if you don't have this information, make your own, put this on your formula page, okay? Phase shift is going to be, once it's in this form, notice how the B is factored from both of these pieces. Once it is factored, then you say, see, the opposite of whatever's in here. So if it's -2 or 5, you say 2 or -5. Okay. I think what's the word they used? Vertical? No. Yeah, this D is a vertical shift, but they use a strange term, midline. Yeah. This is the only book I've ever seen that used, but midline is D, a vertical shift. Thanks. Looking at this question, what is the amplitude? Yeah, you just take the absolute value of -18, right? So if you want to show the work here, I guess. Period. So 4 right there. Yeah, 2 pi. Yeah, it's going to be pi over 2. You're right. Which makes sense. I guess the way you can think about this, the original sine and cosine repeat every 2 pi, right? They go around the circle once and it starts repeating itself. Hence the unit circle. But if you have a 4 right here, it's 4 times faster. So that means the period should be 1/4, right? Because you're going to finish 4 times faster. So you're only going to go 1/4 the distance. That's why you divide that original period by 4. So now this is the actual how fast or how long it takes for it to repeat itself. Does that make sense? So that's why this formula is written this way.
So there's never going to be a -2.
No, no. It will always be positive. It's kind of like time or distance. It shouldn't be negative. C, well, in our case, we don't have a C, do we? So it's not shifted. Any questions about this?
Period, bracket, the first one said that I over an 8.
B. It's this B right here. So RB in this case was that 4. Let's do one more and then we'll move on. Given the following, find the same thing as before. Amplitude, period, and phase shift. Phase shift is just a fancy word for horizontal shift. That's all that is. I don't even know why they call it that way. It's whatever. I've noticed in a lot of math books, there's a lot of complicated words for really simple things. So just look up the definition. Who cares how it sounds? Okay. Math's all about definitions. If you understand them, then you'll be good. Here's the f of x. 12 sine of 4x minus 2 plus 3. It's a 4. So notice how the formula requires us to have the entire thing factored in front of both of these parts here, right? Even if it's not in common, you have to factor. Basically you force it. So I'm sure you've noticed in the homework when there is no factor, you're gonna force it into a fraction, which is a little weird. We don't do that very often. We usually only factor things that aren't common, but that's not a That doesn't mean you can't factor other things. Okay. So pull out a 4. Obviously, this becomes an x. If I factor 4 out of here, just remember, factoring is it's as if you're dividing by that number. So if I'm dividing by 4, it's gone. If I divide it 2 by 4, it's a half, right? And if you have trouble seeing it, what's 4 times a half? Right, we're going to get back here. So it needs to go back to how it was, otherwise you did it wrong. Once it's in this form, the way we wrote it up here, we can answer all the questions. Amplitude, period, phase shift, so what is the amplitude? Yeah, just 12. It's already positive, so absolute values does nothing. Let me put the A to be proper. Formula says it's A, which is 12, which is 12, period. It makes some more space. It just so it looks prettier, not because it matters. Formula is 2 pi over capital B, absolute value. So that will be 2 pi over the 4 we factored. So in this case, it'll be the same as before, right? What is our phase shift? Yeah, we take the C, we do the opposite. So if this was positive, you use minus. If it's minus, put positive. Any questions on 1 and 2? Is that okay?
Positive, it's negative, it's negative.
Yeah, just flip it. So whatever's in here after you factored, the phase shift will be opposite sign.
That goes for both sine and cosine, right?
Yeah, sine, cosine, same rules. Make everything will be the same.
And for number 1, you might. Oh, you got 0.
Yeah, because there's no C. Look at it. There's no C inside. There's a -1 out there, but we didn't talk about midlines or vertical shift. But this would be shifting it down 1. This would be shifting it up 3. So if they would have asked for a midline, you'd say y equals 3.
So you just write down.
Yeah, or y -1 for this one.
So on number 2, the midline would be negative.
But number 1 midline, or number 2 midline is y equals 3. This one would be -1. That's whatever number is outside by itself. That's the midline part. 6.2. I don't think I'm gonna ask anything from there. Don't worry about it. One thing I want you to know is know what all the 6 trig functions look like. Yeah, that's it. So as far as 6-1, that's the main things I'm going to focus on is if I give an equation, can you find the amplitude, period, phase shift? I don't think I'm going to give you an actual graph or anything like that. Just the equation. I may ask you to graph something basic for me, but that's about it. Nothing crazy though. Like, I wouldn't ask you to graph something like this. I think that's too weird. But we'll see. What was he gonna say? Something else. You guys cool on that page? Last section, 6.3. Let's do something simple. Find the exact value of sine inverse of square root 3 over 2. So basically that's asking you which angle has a y value of square root 3 over 2. Remember, sine inverse is on the right half of the circle. So it's going to be 60 degrees, right? 60 degrees. Cosine inverse of negative half, where would that be? On here. Like cosine inverse is this top half of the circle. Or negative half. Yeah, it has to be right there. So all I would need you to do, there's not much work to be shown. So on these, just give me the answer. Okay. Use your circle. Not a huge deal for number 1. Is there any questions on what we did? And you'd have to kind of work backwards. Like tan is defined in the same spot as sine. So let's say we made up our own tangent. Root 3. So since it's square root 3, kind of have to figure out, okay, well, which two, if I divide sine and cosine, which ones will cancel to give me a root 3? So we should kind of see, what I want you to see is this. You see how they will cancel, right? So I need an angle that has this on the top for a sine value and this on the bottom for a cosine. Does that make sense? That's how I think about it in my head. So we look at the circle. Sine, tangent is equal to sine over cosine. So sine needs to be root 3 over 2. Where is root 3 over 2? Yeah, for the y, it has to be this one for y and this for x. So yeah, it's going to be 60. Technically, another solution would be out here, but yeah, it would be outside the range. That's a good question, though. That makes sense? Okay, let's move on. You're for sure gonna have some triangle questions like this. But complete the identity using the triangle method. We did a few of these in our examples. Let's do part A right here. Remember I told you let theta equal the inside part. Use your definition and then build the triangle. So let theta equal the inside. Using your definition, that's the same as saying tangent is equal to some x. That x is the same as x over 1. Build your triangle for this guy. Put theta here. Tangent is defined as opposite over adjacent. That would mean that hypotenuse would be the sum of those squares square rooted. 1 squared is still 1, so I didn't write it, if you're wondering. They want to know cosine based on this information. Let me write that a little better here. Forgot to write let. So cosine theta. What is cosine going to be? Yeah, 1 over x squared plus 1 here. Any questions on part A? Is that okay?
Does it matter where we place data?
Nope. You put theta wherever you want, but once you place it, that will determine where x goes. X over 1. Part B, let theta equal secant. That means that secant theta is equal to some x. Build your triangle. Where does the x go if theta is here? Yeah. Where does the 1 go? Jason. Pythagorean theorem will give us x squared minus 1. I'm going to skip that step. Now that we've done so, they wanted sine. What is sine of theta? Here's theta, opposite over hypotenuse. Any questions on number 2 here? You're for sure going to have one of these on your exam, something like this. You can also have one that has numbers instead of an X, but the approach will be exactly the same. You just use the numbers. That's it. Any questions on 6.3? I don't think there's anything else I'm going to ask from there. Here, no. I don't know if I have it open anymore. Anyway. Let me take roll before I forget. Keep forgetting. Give me a second.